Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about integration. Now the question I've chosen to go through here is 2019 Paper 1 Question 4 Part A. In this question we're asked to get the integral of 4x cubed minus 6x plus 10 dx. So remember, integration is relatively straightforward. I increase the power of x by 1 and I divide by the new power. So for the first term I've got 4x to the power of 3, I increase that to 4x to the power of 4 and I divide by the new power, which is 4. In the next term you should remember that this is x to the power of 1. This is 6x to the power of 1, so it becomes 6x to the power of 2, and then you divide by the new power, which is 2. The 10, you can view that as 10 by x to the power of 0, so the x to the power of 0 increases by 1 and it becomes x to the power of 1 divided by 1. Obviously I don't need to put the divided by 1 bit in there. And whenever you're integrating, if you don't have limits, then you need to add in your plus c for the unknown constant at the end. Now we can simplify this further because 4 into 4 goes once, 2 into 6 goes 3 times. So my final answer is x to the power of 4 minus 3x squared plus 10x plus c. In the second part of this question, we're given f dash x and we're asked to find f of x. We're asked to prove that f of x is the answer given. So you need to remember that if you had the original f of x, in order to get the derivative, obviously you would have differentiated. This means that you've been given the derivative. We need to go backwards. We need to do the opposite of that and go back to the function. The opposite of differentiation is integration. So if we're given the derivative and we're asked to find the original function, I need to go backwards. I need to do the opposite of differentiation, which is integration. So to find the function f of x, I'm going to integrate the derivative. The integral of 6x squared minus 54x plus 109 is 6x cubed over 3. So that was x to the power of 2. It's now x to the power of 3 over 3. This is x to the power of 1. It's now x to the power of 2 over 2. And this is x to the power of 0. So it becomes x to the power of 1. And don't forget, again, we don't have limits, so we have to add in a plus c. 3 into 6 goes 2. 2 into 54 is 27, and the last two terms stay the same. So this is my f of x. But obviously I'm not finished yet because I still don't know what my c is. Now I was viewing the scripts with all the leave inserts that did it in 2019. A lot of them messed this up. A lot of them didn't know how to get their c here. You need to know that the one piece of information you've been given is that the point 20 is on this curve. I know that the point 20 is on this curve. That means that if I sub in x equals 2, the whole thing should be equal to 0. So that's all I need to do. If I sub in x equals 2, let the whole thing equal to 0, I should be able to find the value of c. So I've worked out that f of x, I know the first three terms and I need to find my c. I also know that when x is equal to 2, y is equal to 0. In other words, if you sub in x equals 2, you can let the whole thing equal to 0. And at this stage, all of a sudden I've got one equation, one unknown, so I can find the value of c. If I simplify it down, I end up with c is equal to minus 126. So to finish it off, I suppose all we need to do is just rewrite our function. And that's our final answer for this part of the question. In the final part of this question, we're asked to find the coordinates of b and the coordinates of c. Now you should look back at your graph and you should realize that the coordinates of b and c are the roots of the cubic. And we already have one of the roots. We worked out in the first part of the question that x equals 2 is one of the roots. Sorry, we're actually given that in the question, that x equals 2 is one of the roots. You should realize that if x equals 2 is a root, you can bring the 2 back across. That means that x minus 2 equals 0 is a factor. Once you know one of the factors, you can use a long division to find the other factors. So that's what I'm doing here. I've decided I know that one of the factors of this cubic is x minus 2. And I'm going to use a long division to divide this factor into the cubic, and that'll give me the other factors. So I've done my long division and my remainder worked out as 0, so I know that I haven't made a mistake. And the other factor worked out as 2x squared minus 23x plus 63. Once I know that this is the other factor, if I factorize this and then solve it, that will give me the other two roots, or in other words, the other two times when this cubic crosses the x-axis, and they're labelled as b and c. Okay, so now all I need to do is factorize my quadratic. 2x squared minus 23x plus 63. The factors here are 2x minus 9 times x minus 7. They're my factors, but obviously I'm looking for the roots, the points where it crosses the x-axis. So I let each one equal to 0, and my values work out as x is equal to 9 over 2 and x is equal to 7. So I know the other, apart from the one I already know, which is x equals 2, the other two times that this cubic crosses the x-axis is at 4.5 and at 7. Now you're asked to write the coordinates, so you have to leave your answers like this. Obviously, if it's on the x-axis, in each case the y value is 0. And if you look at your diagram, b is clearly smaller, the x value of b is clearly smaller than the x value of c, so b must be 4.50 and c must be 70. So that's my final answer there. I hope all of that makes sense. If you're unsure on any of it or you want me to clarify it, then just make sure you let me know in class or send me an email and I'll try and explain it a little bit differently.